Hi students! In this lab we'll examine Newton's second law application in the inclined plane experiment. The goal is to try and obtain acceleration value in 3 different ways and compare the results between these 3 methods and the methods themselves. While performing the analysis, you'll be able to learn about how some sensors work. Note that this video is not a substitution for the manual, and there will be many tasks as well as explanations omitted in the video, so make sure to read the manual first. For our experiment, we'll use a track, a motion sensor to measure the speed and acceleration, a cart, a set of masses, a string, and a wheel to help reduce the friction of the string. We will also use Data Studio software to record and save our data from motion sensor. Now, of course, we still have some friction which will affect the data. We'll try to account for that friction and other errors like air resistance by getting a cart to move steadily on a leveled rail and measuring the standard deviation of the cart's velocity. Here's the data for that part. Now, for our first experiment, let's measure the cart mass. Next, let's measure the angle of inclination. We will do it by measuring the triangle's sides. Since the rail creates a right triangle, we can get the angle of inclination from measuring the lengths of its 2 sides. Next, let's launch our Data Studio, create a new experiment, turn on the velocity and acceleration measurements, and increase the sample rate since our measurement is dynamic. Set the cart on top of the rail and start the measurement while releasing the cart. As you can see, our graph has a clear part where there is a steady increase in velocity. This is our point of interest. At the start of the graph, the cart was way too close to the sensor, where it doesn't function properly, and after that there was a fall. However, we will only use this nice sloping segment. Let's select this data and copy it to Excel. Now we will select the same time segment on the acceleration graph. What we are interested in is acceleration. We will get it in 2 ways in this experiment. One will be from the slope and slope error of the velocity graph, and another is from the acceleration graph's mean and standard deviation. Read the manual to see what you need to do in the analysis with this data. Now for part 2 we will tie a string to the cart, change the angle of inclination so that our motion sensor is at the bottom, then add this little wheel on top of the track, and add a mass to the other end of the string. Now instead of rolling down due to gravity, the mass will pull the cart up the slope and it will accelerate upwards, opposing the gravitational pull. Here's our data for this part. The Excel file with this data is going to be on Moodle as well, but the acceleration's mean and standard deviation you need to look up right here. And we're almost done. We also needed to know the angle of inclination for the second experiment. Here's the data for that. And the mass of weight that was pulling on the string. The experiment is over. Please answer these questions in your discussion section after you finish the analysis.